RAID is how I started. RAID set the context for how I look at the world. I'm interested in large amounts of data, high levels of reliability and availability, and high performance. I started doing RAID. It wasn't even about RAID. It was about high performance computing, and I wanted to make things go faster by putting them in parallel. And that took me into lots of failures, took me into protection for failures. But since then, we've gone off and done object model file systems. Panasas has the object model file system. Some of my students that worked on it at CMU went off and wrote the Google file system, or participated in writing that, and Bigtable system. And another company the Lustre file system is a copy of the architecture that we built in here. So no, I think the impact of thinking the RAID way is not anywhere near over with. Redundant arrays of inexpensive disks was a catchphrase of our paper, the taxonomy describing different ways to do redundancy in parallel storage. And for us, the inexpensive comes from PC technology. And the arrays concept is that you're using them all together. And so it was redundant arrays of inexpensive disks. Well, when the market took off, something about calling your products inexpensive didn't work well for a lot of the companies. So the companies got together and said, you know, the acronym is great, RAID is a great acronym, let's keep it, but let's change inexpensive to independent. So when I was asked my opinion of this by, there was something called the RAID board in the early 90s, my reaction was, well, it's the same acronym, and the meaning is accurate, that they are independent disks, and that allows us to take advantage of the independence. So I'm okay with changing the acronym. But yeah, so RAID is redundant arrays of inexpensive disks, and it's also redundant arrays of independent disks. For me, the very beginning was when the group of us that were at Berkeley and building complete file systems, hardware, operating systems, compilers for Lisp-based systems, realized that the industry was going to start building RISC-style microarchitectures and go quite fast. And so our emphasis moved away from computer architecture to networking and storage. And I was the one that went off and said, so what's going on in the storage world? And what was going on in the storage world was that the great big 14-inch washing machine-sized disks were being replaced by small disks because of the PC movement. The 1984 PC needed to have a disk that was comparable in size to the desktop or smaller, so that you didn't have to have a washing machine beside your desk in order to feed your desktop. And so SCSI had come along, and it had made disks small and independent. And we looked at that architecture. It was on a network. I could talk to it multiple at the same time, and said, you know, for the same volumetric density of that washing machine, I can get a lot of disks in. So, and if I can spin them all at the same time, I can get a lot of bandwidth. So our initial idea was that the consumer marketplace created by PCs funded the development of small disks that we could then capitalize on to run a lot of them in parallel. RAID was as a result of realizing that the failure rates were going to be higher, and we were going to have to do something about that. And that led to redundancy. So the early concepts that we were thinking about was PC hardware, PC disks. That's the reason in the beginning we called it inexpensive disks and not independent disks, was because they were coming from commodity hardware. And we're saying, how can we use that to make systems better? The drives getting bigger has both moved the market along and caused problems for it. Because the drives get bigger at roughly the same price, customers see that the price per byte is dropping constantly. And that motivates them to want to capture information that the value of it to them is lower, but now the price to store it is lower. So there's a great sucking sound of all the data out there that you didn't used to think was worth enough to store, that you can put on and try to make value out of. So higher density drives absolutely motivates that entire marketplace. And if they stop increasing the density, it's going to have a serious effect on the way that marketplace works. But it's also a problem for us. The problem for us is that the failure unit is the disk. And so I can't have just 100 megabytes fail. When the disk fails, I lose terabytes. And it used to be 100 megabytes when I started RAID, and then it was up to a gigabyte, and then it got to 5 gigabytes, and now it's approaching 5 terabytes. The failure recovery is the amount of work I have to do to recover a lost component, and that is scaling up with the density, which makes the recovery work a bigger and bigger part of what we do to make a good RAID solution. And it's why we developed declustered parity early on to try to make the RAID recovery a parallel application, not just a per disk local application, but the entire system is involved in the RAID recovery, so we can make the time to recovery get smaller. And the drives getting bigger means that we have to do a lot of work, but the amount of time we can keep small with a parallel application. But that large amount of work still has to be done. That's still resources people take. And so we've started to worry about the probability that during the recovery there are subsequent errors. Secondary errors when you're doing the recovery leads to losing data if you only have one level of protection. The original RAID paper was about one level of protection because we had 0 at the time, and having 1 was a really big step forward, and 2 was perceived to be overkill in terms of reliability and very expensive in terms of the performance degradation. So there was a lot of resistance. We did papers on double protection and triple protection right off the bat in the early 90s. We just didn't see them penetrating the marketplace because the risk of data loss wasn't great enough. It is primarily because of the increasing size of the disks that we've had to worry about higher levels of reliability. The reconstruction takes longer in many systems, so that you're exposed for a longer period of time. And while you're reconstructing, you're exposed to media errors. And if you run into a media error, then that reconstruction fails in traditional systems. And so it isn't really the loss of a second disk that drove some companies to go from RAID 5 to RAID 6, but the media errors that could occur. So in particular, we decided that the best way to handle that was not a complete level of redundancy for media errors, but to add in each drive vertical parity code that protects against the loss of an individual media sector instead of losing the loss of the whole drive. And that's a point solution targeted at the type of failure modes that were motivating some people to go to RAID 6. And it's a better way to deal with that problem. But there's still enough systems, enough disks that are doing a long enough recovery that we need to increase the reliability. And that's ultimately being driven by the increasing size in the disks.